Quantum physics is one of the scientific fields most frequently misused by pseudoscientists. Due to its ability to challenge our classical perceptions and its seemingly mystical qualities, quantum charlatans exploit this to weave fairy tales and swindle innocent people out of their money. For example, they claim that the human soul has a quantum nature and is not located inside the body, but is instead non-locally distributed throughout the geometry of space-time, outside the brain. These terms and statements are not fabricated. They are directly quoted from figures like Deepak Chopra, a New Age guru and a leader in quantum quackery. These claims lack any solid scientific foundation. Essentially, these charlatans take terminology from scientific theories like quantum physics and relativity, mix them with abstract concepts like the soul and mind, and turn them into a confusing word salad to offer pseudo-advice. If you were to challenge these quantum charlatans on fundamental physics, such as ninth-grade physics questions, they would likely fail to answer even a single question correctly. Their goal is not to uncover the truth, but to sell fantasies and make money. When confronted, they deflect by accusing critics of being close-minded or not understanding ancient wisdom. Contrary to their claims, scientists genuinely investigate whether there's any connection between quantum physics and consciousness. However, they do not use the highly uncertain and controversial findings of this complex field to make unfounded claims, sell seminars, or act as life coaches. Quantum physics remains a highly debated and innovative field because its effects are typically observable only at subatomic scales. As objects become larger and more complex, quantum phenomena like entanglement dissipate, and classical physics takes over, leading to the behavior of everyday objects. Challenges in bridging quantum physics and classical physics. At microscopic scales, quantum physics dominates, but as we move to larger scales, classical physics becomes more applicable. This transition poses several questions. At what point do quantum effects fade and classical physics becomes dominant? How does the shift from quantum to classical physics occur, given their incompatibility? Moreover, do quantum phenomena influence the classical world? For instance, in a seemingly predictable system like a rolling die, classical physics would allow us to predict the outcome if all parameters were known. However, if quantum physics continues to affect the die's movements, the outcome remains probabilistic and unpredictable. This inherent unpredictability highlights the deceptive nature of quantum gurus who promise predictability based on quantum mechanics. Quantum processes and consciousness. Scientists are exploring whether quantum processes within the atoms and molecules of our brain cells relate to consciousness and perception. The prevailing view in neuroscience focuses on how neurons fire and connect, which has fueled advancements in artificial intelligence by replicating neural connections on computers. However, this does not fully explain how consciousness arises from neuronal activity. The exact mechanism that transitions from neuronal firing to the creation of a clear perception of reality remains unknown, often referred to as the hard problem of consciousness. Another critical question is whether internal factors within neurons influence firing, beyond just membrane processes. Current neuroscience suggests that only membrane events like ion movements and action potentials determine neuronal firing. However, simultaneous intracellular processes might also play a role, creating a gap similar to that between quantum and classical physics. If this gap is significant, it implies that consciousness, thought, and perception involve more fundamental processes than just bioelectric impulses. The role of microtubules in neurons. Microtubules, though seemingly technical, are simple structures crucial for cellular functions. They coordinate chromosome movement during cell division and maintain cell shape and structure. In neurons, microtubules are tightly bundled, unlike in other cells, which allows for efficient transport of organelles, proteins, and signaling molecules between the cell body and synaptic terminals. This organized structure enables neurons to maintain their shape, support rapid signal transmission, and resist deformation. From a quantum physics perspective, the symmetrical and protected environment created by tightly packed microtubules in neurons is essential for maintaining quantum processes at larger scales. In chaotic environments, quantum properties like entanglement are difficult to sustain. However, the organized structure of microtubules might allow subatomic particles to retain quantum information, facilitating communication within neurons. Orchestrated objective reduction, Orch OR. Theory. Building on these observations, the Orch OR theory posits that consciousness arises from quantum processes within microtubules in neurons. This theory suggests that as neurons grow and become more complex, quantum interactions within microtubules lead to the collapse of the wave function, linking quantum mechanics to consciousness. Sir Roger Penrose and Stuart Hameroff are key proponents of this theory, which remains highly controversial and lacks substantial empirical evidence. Many scientists, including Max Tegmark, criticize the Orch OR theory, arguing that quantum decoherence occurs too rapidly within the brain for quantum processes to influence macroscopic events like consciousness. They also point out that biological parameters assumed by the theory, such as the number and size of microtubules, are incorrect. Additionally, Hameroff's biological assertions, like the number of microtubules in neurons, their lengths, or their dimensions, are seen as flawed, and he appears to misunderstand the source material. Thus, the hypothesis can't address the evident difficulties it faces. Conclusion. Currently, there is no definitive quantum model of consciousness, and the debate over whether consciousness is quantum in nature remains unresolved. While the Orch OR theory and similar hypotheses present intriguing possibilities, they require extraordinary evidence to gain scientific acceptance. Nevertheless, exploring these theories pushes the boundaries of our understanding and could potentially bridge gaps between quantum physics and neuroscience, offering new insights into the nature of consciousness. If you found this video insightful, consider watching our discussion on philosophical zombies, where we delve into why we possess consciousness. See you in the next video. Take care.